Hello everybody, this is Holden again and welcome to the video where I will go over what you need to know for the fifth homework. So let's start off with making a scatter plot. Use the plot data x, comma, y. How you determine which is x or y depends on which is the explanatory and which is the response. The response variable is the y variable and it is dependent upon the x variable. So in this circumstance, cells depends on the number of people working. As we can see, since we plotted it, it looks like a positive correlation, but let's get the number that shows us what the correlation actually is. So we can do data x comma y, or correlation, COR, data y comma x. It works both ways, so I'll put in a note, correlation x comma y, or cor y comma x, whichever you prefer. If this ever comes back as a 1, you probably put it in wrong, so always check. If you type the same like x comma x or y comma y, it will return a 1, so be wary of that and make sure you type it in correctly. So next let's make the linear model. LM data y and then a tilde data x. Now we get the intercept and the slope. As you may remember, the format is y equals mx plus b. This is called slope-intercept format. So we'll be using the same thing. So in this particular example, cells is my response variable or y variable because it responds to the number of people working. So cells equals slope as it gives us 0.8538 times x, which is number of people working, plus b, which is 9.2493. You can't put it into R like this, so in practice, let's say there are 10 people working for the purposes of this example. So we would do 0.8538 times 10 plus 9.2493, that's y equals mx plus b. And the value that we would get if there are 10 people working is 17.7873. This is the predicted value based off of the model. We're using the values we get and we're putting in an x value and we can get whatever is predicted. So let's say in reality, when there are 10 people working, the cells are 20,000 instead of 17.78 thousand. So residual is observed minus predicted. In this instance, we observe 20 as that's what we actually get, but our model predicts 17.783. So in this circumstance, our residual would be 2.2127. Next, let's make the least squares regression line actually appear on the scatter plots because it's nice to look at it visually. So to do this, type in model. It doesn't actually have to say model, this is just a vector. So model, you could either do it this way or just put an arrow key and then copy and paste what worked when you did the linear regression. And now we've made a model named model, and as we can see it's a linear model because we have LM. So type in AB line, AB line model, and it puts our line on the scatter plot. This line minimizes the sum of the squared residuals. So it's important to conceptually understand what it's doing. It is not the one that goes through the most points, it just minimizes the sum of the squared residuals. So now let's make a residual plot. To make the residual plot, you plot x, comma, and then your residuals of model. This is the kind of general format. In practice, we need to use our actual x. Do not type x. Type what the x actually is. Number of people working, comma, resid. We've named the model model. Keep in mind, whatever you type, whatever you name the model is what you need to use here. It could be model 1, model 2. If I'm making multiple models, I name them in numerical order. So this is the residual plot. type in AB line 0, 0, and it just puts a straight line at 0, so you can check your assumptions for regression. On question 4 of the project, it asks you to check the assumptions. So as you remember, to check some of your assumptions, you need to look at the residual plot. So this is what you would make and put in your presentation. Thank you for listening. As always, come to office hours or email me at holdenarcher1@gmail.com with any questions you may have, and I'd be happy to get back to you.